Supernova, a star that suddenly increases in brightness because of a catastrophic explosion that ejects most of its mass. A significant proportion of the matter in the star is blown away into the surrounding space at extremely high velocities, up to 10% the speed of light. During the duration of a supernova, three things could happen. The star could form a black hole, or a neutron star, or a gravastar. To understand how a gravastar or nest star works, we first need to understand how black holes and neutron stars are formed. Let's start with neutron stars. When a massive star runs out of fuel and collapses, the core of the star crushes together. Protons and electrons cushion together into neutrons, ergo the name neutron star. The neutrons make the neutron stars superdense, like extremely dense. And next, the black holes. Black holes are formed when a massive star collapses in on itself, or when gas in a galaxy rotates in the opposite direction of the stars. Gravastars are actually made to be an alternative to black holes. In fact, a gravistar could be a black hole, or vice versa. Now that how gravastars are made and are related to black holes and neutron stars, let's talk about the weird properties of gravastars. First, gravastars are almost as compact as black holes and have a gravitational influence at their surface, basically as strong as black holes. But there are some big differences. Gravastars don't have an event horizon, hence they don't seal light. Secondly, there isn't a singularity at the heart of a gravistar. Instead, they have hearts of dark energy. Gravastars also have a near infinitely thin shell of unknown matter. The shell of a gravistar is the coldest thing in the it's one of the coldest things in the universe, only a billionth of a degree above absolute zero. If we looked at it in deep infrared, the cosmic background would look warm around it. But how could the shell be so cold? Don't all atoms move around producing heat? Well, it turns out the shell isn't made of atoms. It's made of an entirely different material. The shell of a gravistar is actually so thin that atoms look massive compared to it. What's inside of a gravistar? Well, when we look inside, things get even weirder. When we look inside of a gravistar, things get even weirder. The inside of a gravistar is kind of simple. Actually, there's nothing inside. It's what you think in a traditional sense. A perfect vacuum without a single particle, atom, or wave. But vac- and even though it seems empty, this vacuum is bubbling with the most fundamental type of energy. To explain this, we'll have to use some metaphors to understand what it is. According to our current understanding of physics, particles, any particles, quark, electron, protons, and so on, are not solid objects, but waves in an ocean. And on Earth, you can't have waves without water, and just like the inside of a gravitar, you can't have all those without an omnipresent fluid. This fluid is the vacuum of, of inside the shell of a gravitar. This is what we perceive as nothingness, and this vacuum has has energy. The vacuum is actually everywhere in the universe. Your and your room is 99.98% vacuum. There's actually vacuum in the spaces of your cells, or in between atoms, but it's a bit different with a gravistar. It's as if the universe took a pump and compressed the star as much as it can allow into a kind of super dense nothingness. In fact, the vacuum of a gravistar is way more dense than the vacuum around it. This is a crazy amount of mass and energy in a tiny space. Just like a black hole, because gravastars are so cold and full of mass, gravastars look and behave almost identical to black holes. Both massively curve space-time around them and create lots of fun tricks that we know black holes for. If you were to fall into a gravitar, you'd be dead before you touch it, like a black hole, being stretched by spaghettification and the extremely large forces of gravity. When you touch the gravitar, your atoms will be completely disintegrated and turning them into the vacuum space inside the gravitar, adding a bit more mass and energy to the gravitar. So what's the point of this theoretical object? Well, black holes were theorized more than a century ago by Carl Schwarzschild as an abstract solution to the equations of gravity. For more than 50 years, they were considered mathematically valid, but too absurd to reveal. None believed that they actually existed, but scientists kept looking, and then we saw stars being thrown around by invisible titans. We saw light stretching around invisible gaps in the sky, and as our technology and our theories improve, we kind of took a picture of one, M87. We have evidence for them and they fit our theories, so it kind of makes sense nowadays to believe they're real. Black holes are really cool, but they create a lot of problems, like the singularity seeming to delete information, which should not be possible, and a lot of questions which have upset scientists. Gravistars are a pretty new idea that fixes some of those problems about black holes, but they kind of have their own problems too, like weird matter that makes a super cold and tight shell, super dense nothingness, the supermassive empty core. Just like black holes, they make sense and seem to fit our theories. But hopefully, in the near future, we'll be able to determine whether black holes or gravistars are real. Um, Thanks for watching the video. My sources are Kirkazart mainly, and like space.com and sciencedirect.com. So, yeah.